गुड इवनिंग पंकज सर। पंकज सर, आप अपना स्लाइड एक बार शेयर कर लिए ताकि है ना, कभी कभी इशू आ जाता है तो वो चेक कर
ओके
लेंगे तो।
ओके ओके। आप इसको ना, आप डिसेबल कर दीजिए। ये
हाँ सर, मैं कर
डिसेबल है,
देता हूँ।
सॉरी, एनेबल कर दीजिए।
हाँ, मैं कर देता हूँ।
गुड। ओके। आपको edit करना पड़ेगा।
हाँ सर, मैंने कर दिया सर।
अभी विजिबल है ना? अभी डॉक्टर साहब विजिबल है?
विजिबल है सर।
ओके ओके।
सर अभी 1 मिनट और 1-2 मिनट और रुक लेते हैं।
ठीक।
वैसे हमारा पार्टिसिपेंट 80 के आसपास, 90 के आसपास होता है, तो 1-2 मिनट वेट करके सर उसको शुरू कर देंगे।
ओके, अच्छा, लैंग्वेज इंग्लिश या हिंदी क्या रहेगी? किस तरह की ऑडियंस
सर
है?
आप दोनों जिसमें आपका कंफर्टेबल है सर। एनी।
नहीं, मेरे को कोई दिक्कत नहीं, लेकिन ऑडियंस।
हाँ सर, हाँ सर, वो ऑडियंस सर वो इंग्लिश का ज़्यादा है सर यहाँ पे। इंग्लिश, हिंदी भी आपका बीच बीच में आप बोल सकते हैं। वो कोई हिंदी हिंदी वाला ज़्यादा है, मगर साउथ का भी है सर, इसलिए इंग्लिश में ज़्यादा प्रेफर करेगा सबके लिए सर।
ओके। ठीक।
डॉक्टर मनीष, मनीष ने ज्वाइन कर लिया क्या? आई थिंक वी कैन स्टार्ट। जो सर शुरू कर ले।
Yes, please. I came just now. You please go ahead.
Yes, sir.
Just give a brief introduction about the speaker, please.
Yes, sir. Yes, sir. I'm good. Yeah. A good evening, everyone. A very warm welcome to all the participants on the day 14 of our 21 days online training program. Today, sir, we will focus on post-harvest management and storage of maize. Sir, we all know that effective post-harvest management is very important for reducing storage losses and preservation of grain quality and strengthening of the maize value chain. So, our first speaker is Dr. Pankaj Kumar, Senior Scientist at ICR Central Institute of Post-Harvest Engineering and Technology, ICAR-Indian, Ludhiana. And Dr. Pankaj is a researcher specializing in post-harvest engineering, grain processing, and value addition in of agriculture produce. And sir has developed maize drying technologies. Also, he has developed one model of maize dryer, which we will be presenting during her expert talk. And today he will deliver an expert talk on post-harvest management and storage of maize. So with this introduction, I warmly welcome Dr. Pankaj Kumar to deliver his expert lecture. Sir, over to you, sir.
Thank you, Dr. Saab. Thank you very much. Am I audible?
Yes, sir.
Okay, I am sharing my presentation. So presentation is also visible, Dr. Saab?
Yes, sir.
Okay. So good evening, all of you. I am Dr. Pankaj Pawar from ICR CFET, as Dr. Saab introduced me. And I also thankful Dr. Saab. It's a great opportunity to share my research experience with the stakeholders. So my topic is post-harvest management and storage. As you see here, harvesting, drying, and storage, all these components of the maize value chain. But it is started the management of post harvest. It is started just harvesting. So we have to understand the timing is very crucial for harvesting. So moisture content generally we observe 25 to 30%. But there is one point which I would like to draw your attention on this point. Before selling, that 25 or 35% of moisture content should be reduced up to 17 to 18%. Otherwise, our grain would be broken or quality will be affected seriously. I mean, some aflatoxin or contamination would be environment would be more conducive. So we have to reduce our maize cope up to 17 to 18% before shelling. And one more important thing is when we harvest the product, so we have to optimize the moisture content. Otherwise, these micro cracks in the grains, it is very conducive for aspergillus flavors and leading to the aflatoxin, as I said. So before means shelling, we have to dry our maize co-produce properly. And you can see in this slide, harvesting moisture percentage is 30 to 35% sometime. And we have to reduce it up to 17 to 18%. But predominant method for maize cob drying is still open sun drying at farm level. You know it takes 10 to 15 days and it is weather dependent. So we have to think over it. Dry location, sometimes fields, sometimes roadsides, and even open space you can see anywhere in the country. So the risk factor is reweeting and fungal contamination, and ultimately quality loss, and our product would be in serious condition. So my concern is we have to dry properly. Oh, then we will think about the best quality of end product. And the existing scenario is you can see there are a lot of dryers are available, but most of them are from grain drying. But for cob dryer is not available, which is specially designed for maize cob. These are some I have seen some dryers, but these are actually designed for other purpose. But people using them, but these are having faulty design. So a proper cob dryer is very much required for cob drying purpose, and it's a very crucial technological gap. Limited farm drying systems for intact maize cobs are available, and those are available. They are costly or energy intensive, and there is no portability or farmer level solution. So, based on this background, we have started actually in 2021, we have started to develop a GFRP based humidity responsive maize dryer for decentralized use. GFRP is a material, actually, it's a fiber based material. You can say it's glass fiber reinforced plastic. So I can explain it in the next slide. But with this background, you can understand why we have developed a new dryer. So we developed a new dryer based on this because there are no availability of the cob, especially which is especially designed for cob dryer. So that is why we have developed, CFET have developed a efficient maize cob dryer. So you can see in this slide, this is the main slide. Actually, the overall length, width, and height of the dryer is around 2.44 meter is in length and 1.22 meter in width, and it's 1 meter is height, and total capacity is 1000 kilogram, means 1 ton of freshly harvested cob. You can dry it. And the structure, as I said, it is GFRP and protective covering. So you can see all the material is corrosion resistant. There is no bother for corrosion, and shelf life or duration or durability, you can see it. It is very durable. And the open roof, the open space means roof of the dryer is transparent. So I will explain it. What is the key design feature of this novelty? So you can see the unfolded bed in your left side upper corner. You can see these photographs. So first photograph, this is the drying bed. So this bed is totally made up of GFRP, and GFRP is corrosion resistance, and its tensile strength is more 3 times more than steel, and the density is 2.5 times lower than the steel. So it means it is lightweight and corrosion resistance and suitable for field operation or field condition. You can see this dryer is foldable, means the bed is foldable, and after folded you can see this picture. So it is just 4 into 4 by, means 4 feet and 4 feet. You can store that dryer in a very less space in off season. One more thing, how it's work, because greenhouse assisted drying, the transparent roof, as I show you in our previous slide, the transparent roof of solar that heat or heat gain from the solar rain, and that is elevate the chamber temperature and improve the drying microclimate. And another feature is it is humidity responsive airflow control. We have used simple Arduino and some humidity and temperature sensor. You can see in this picture, this is the control box. So the program is when the humidity more than 60%, the fan is automatically on. And when it's below 55%, fan is off. Means if it runs continuously, so it cannot be utilized properly the greenhouse effect. So we have stopped the fan if humidity below 55, degree, 55% of humidity, and in that condition, moisture from the cob goes to the air because of temperature elevation. And when the humidity become more, so fan automatically start with the using of this Arduino program. So this prevent the moisture accumulation. So no need of human intervention. It's automatically do this job. And airflow and portable design. The centrifugal fan in suction mode. Generally, you see the in dryer. You can say that the dryer is not suction mode, but here we use this drying bed perforation as a air pass system. So we not push the air, we just suck the air through our aspirator unit. So air comes from the bottom and pass through the material. So all the cobs exposed to that air, and you know the porosity of maize cob is very nice. It's more than 50%. So our every cob is exposed to that air. That is why we will achieve the uniform cob dry. And foldable bed and assembly, you can assemble it in few minutes. It's very easy to assemble. Working principle of that dryer, you can, most of them want to know what is the working principle. So you can see this dryer, the solar radiation goes through that transparent roof into the chamber, and chamber is heated, and due to that heating, cobs release moisture and increase the relative humidity. And because of that, humidity is sensed through the sensor that detect the RH and command to the fan on. So fan is started, and then exist, जो moist air would be exist, and solar radiation, then this cycle is continuously running and your material is going to be dried. Field performance of, we have tested that dryer after its fabrication or completion or development. We have tested it in 2-3 times at CFET, and even the cob provided by the IIMR, that is also our co-PI, one scientist from IIMR. So he provided the maize cob. So initial moisture content which we have observed, that is 360, means 36%, and we have to dry, as I said, 17 to 18%. So 36 to 17% we have dried it, and the major observation is in this condition the microclimate temperature is around 5 degrees Celsius higher, and relative humidity is 9% lower. And we have also found uniform drying, and there was no fungal growth. So we have achieved this without any auxiliary heating. We did not give any extra heating or dry, or means through electrical heater or any kind of drying. We didn't provide here. And you can see the drying rate. Actually, first up to 25% moisture content, drying rate was very high, and gradually it was decreasing, and at around 20% of moisture content, it's near 1. So you can see this is very nice observation. Actually, generally we dry the cob about 20%, because it is very difficult to dry maize cob below 20% moisture content. It takes more time. As you can see here, the drying rate is very low at that moisture content. That is why we have completed the whole drying procedure in 8 days, because 8 and 9 days there is no significant difference, but we have to stop the drying at 9 days to observe that there is no significant difference between 8 and 9 days. Then we can say now it takes 8 days, and it is 30 to 35% faster than open sun drying. operational and practical significance. So you can see the overall the energy consumption. This energy is electrical energy. So 20 kilowatt hour per batch means 20 electrical heating is used only for 1 ton of maize cob. This is very, very low compared to the other contemporary dryer. But consider one thing, we did not provide any auxiliary heating here. And the specific energy is very low, 0.086 kilowatt per kilogram of water removed. It is very, very low. And the total weight is 89 kilograms. So it is portable. This is the total weight, but it is foldable or reassemblable. You can detach all the pipes, all the fittings. So the maximum weight is of our bed, drying bed, and which is also made of GFRP, as I said. So the weight is only 30 kilogram of bed, and the pipes, fittings, everything, we include everything. So the weight is 89 kilograms. So we can say it is very easy to easy to move from one place to other place. And the
6 వరకు ఉంటావు మాధవ్ నేను
assembly,
ఇక్కడే ఆఫీస్ లో ఉంటాం మావాడు వెన్న
kindly mute yourself. And the setup time is 15 to 16 minutes. Means we can assemble it or deassemble it within 15 to 16 minutes. It is very easy. And as I said, and I especially intentionally focused on this point, there is no auxiliary heating. So we can say the system is field deployable and easy to use in the farm level. And we have also tested this system under the raining condition during Kharif season. So we have observed at CFET 2 or 3 days in rainy season, not rainy season, in Kharif season, but during the rain events under field condition. So we have not observed any kind of defect or any kind of mishappening with our system. Our protective cover ensures safe and stable operation during raining event. So our maize is intact. We have checked that. So you can say in rainy condition, we can use it. Now, as far as techno-economical consideration, you can see this is very important things, because every technology will be sustained or feasible based on these techno-economic considerations. So as I said, the cost is very, very means if we compare to the contemporary dryer, so 45,000 only. And this is our research output fabrication cost, not commercial level. When it will go commercialized, so I hope the total cost would be around 30 to 35,000 rupees, and very low maintenance, because there is no any sophisticated system. It is very easy, very simple, but we have used smartly the greenhouse effect to dry our material. And operation cost is 140 to 180 rupees per batch. This is the 140 to 180. It is based on the commercial rate of the electricity, and no any other fuel is required. Even if you want to reduce these 140 to 180 rupees per batch, it can also be possible. You can use one solar panel to run the fan, because fan is it's required very nominal electricity, or it's a 0.33 kilowatt. So you can use it very easily, operate it by the using of any panel, solar panel. And economic benefits, you can see 30 to 30% faster and reduce spoilage. And the payback time, if one can purchase this dryer or use this dryer, so how much time it will take to pay back? So it is 1.5 to 2, but I have written intentionally 2 seasons. So within 2 seasons, you can recover your money from this. So in shortcut, we can say the developed dryer shows promising economic feasibility, and for small holder FPO and decentralized maize cob drying system. Please underline this line. we have developed this dryer for decentralized maize drying system. Means our small farmers who can dry their produce at the farm level. So this is why we have designed this dryer. And role in maize value chain, it is very effective for maize value chain, because if we want to strengthen our maize value chain, so we have to divide the drying in two parts. One is maize cob drying before selling, then selling, and then grain drying. Then only we can maintain the needed or required value of our product. So enable timely drying at the farm level, reduce risk of reweeting or fungal growth. You can see in Kharif season in Ludhiana or northern India, I have observed in 3 years during September, October, rain events are very frequent. So if we dry our cob in normal field or bare land, so there would be a very crucial condition as far as the quality is concerned. So in this case, if anyone can use this dryer, so they can easily avoid these conditions. Improve grain quality before storage. If we want to make our product would be better in storage, we have to store good quality product suitable for FPOs and small processing unit. So in nutshell, we can say this dryer fulfill a gap, and gap is because people generally dry grain, not cob. But as I said, if we want to strengthen our maize cob value chain, we have to divide this drying system into two parts. One is cob drying and another one is grain drying. So for that maize cob drying, we have developed this drying. And one more thing, intentionally we don't want to input energy at cob level. That is why we didn't use any auxiliary heating. We use only normal greenhouse heating and use it smartly by using some electronics. We have also developed one more dryer, that is hot air maize cob dryer. Suppose some want some faster dry. So you can use that dryer. The drying time is only 24 to 24 hours, and energy consumption is 30 kilowatt per batch. Thermal efficiency is 78%, and cost is around 1 lakh rupees, you can say. So suitable for small scale, controlled and faster drying application. Suppose someone wants to at lower level seed production or something which quantity is lesser, so he or she can take this dryer. It is very effective. And in this dryer, there is auxiliary heating. Electrical heater is being used for heating the material. So it's depend upon you. If you increase the temperature, you can dry your maize cob in 10 hours only. But we have optimized at 50 degrees Celsius. It takes 24 to 25 hours. So as far as storage is concerned, so I have already said that if we want good quality of material in store product, so we have to planning before storing. So I have put here some PICS bag. Maybe you all of aware about that triple layer airtight solution. Nowadays it is very it is being used even in rural areas, I have seen. So it is good for small level of storage. And one thing which is very important, you have to think about the proper moisture content before storage. It should be 14 or less than 14%. Otherwise, your product will be deteriorate. And metal bin, you all are aware those, so you can use them. And FPO silo bags and steel nowadays, this is also popular. who wants to improve their storage structure, they can adopt these things. And structural hygiene is also important. Suppose you have these kind of structure, but you should regularly clean them and practice rigorous grain residual or all kind of sanitation hygiene you have to maintain there. Then only you can maintain your quality. Managing store quality and dosage. So most important, actually, not only in maize case, but every case, there are very crucial thing is moisture content. Moisture content is very crucial. So you can say 12% moisture content for other grain. You can you use that moisture content. 12% is very nice moisture for storage, but up to 14% it is safe for aspergillus. So I have written here also for aflatoxin, more means less than or equal to 13% is okay. So we have to think about this. This is very crucial thing. And proper grain cooling strategy. It's not you put your grain in a bag or in a silo structure, but we have to think about the proper grain cooling strategy, means aeration kind of things, because grain is also a living thing. It's also respire, and during the respiration temperature increase, humidity increase, so we have to make some provision to maintain those parameters. And routine grain inspection, it is also important. Inspect your grain every 15 days and detect, you can smell them, and there are so many technologies or so many methods are available, but thing is you should be aware about that. Bridging gap, post harvest value addition. So from field to factory, so integrated approach. Suppose we want to strengthen our value chain, we have to think differently. Integrated approach means harvesting, drying, storage in a continuous chain, not isolated steps. We have to make them continuous, every step. Then we can manage it, our post-harvest produce. And economic impact, then 10 to 15% post-harvest loss. So by using these things, we can avoid these losses. Quality is non-negotiable. You can see in India, many companies import maize from other countries because only quality. So you can think about that. Quality is non-negotiable. So our motive is to produce high quality maize, and for those things, or to achieve that objective or motive, we have designed, developed different kind of things, because it is very crucial to produce high quality value product. And next step in the value chain, safely stored maize is the foundation for profitable food products. So nowadays there are many structures, there are many kind of, as I have discussed in earlier slides, so we can use them. So from safe storage to high value product, the value addition is very important. So by using these steps, we add the value of our product. So main motive of this presentation is we should understand this thing. We cannot dry our grain in a single shot. Means grain drying, we have to divide this drying into two steps. First, hope drying, then grain drying. Because the quality loss started from home level. Then only we can get our objective. And in conclusion, we can say this is the leaflet of our maize cob dryer. You can see there are 3-4 pictures. It is preserve nutritional quality, save labors, reduce microbial infestation, and boost smallholder income. Actually, transform your harvest, maximize your returns. So this is the motive of these things, and it is very effective for on-farm cob drying, because as I said, the energy consumption is very low and energy efficient, portable, and farmer friendly. So it is a practical solution for scientific drying of maize cob at farm level. And I would like to say that we got patent recently, before 10 to 15 days before we got patent on this machine. We have published papers, and we are searching for a manufacturer, because CFET is a research institute. We cannot multiply these dryer. We have research, we have developed one thing, and after that, some manufacturer come and take this technology and then produce it. So I also wants to tell all these groups who are listening me, if you are interested to manufacturing these kind of machines, so please contact us. We have a proper technology. We guided you and take this technology from CFET and make it available for the normal farmers. Thank you. Thank you so much.
Thank you so much, sir. If anyone has a questions that you want to clarify from sir, then you can ask. Only 2-3 questions we will take up. अगर किसी का सवाल है तो सर से पूछ सकते हैं ड्रायर से रिलेटेड, और सर का जो खासकर जो सर का ड्राइंग और ओवरऑल पोस्ट हार्वेस्ट मैनेजमेंट से रिलेटेड अगर किसी का है तो.
And please, Dr. Saab, I also want to give one message to all of you. If you really want to take this kind of machine, so please come forward and contact us. This technology is ready to give, so you can take license from CFET and manufacturer it, and then make your business profitable.
Okay, sir. Noted, sir.
Okay, thank you. Thank you all.
Thank you so much, sir, for your for the presentation, and you have covered it well, and you have covered extensively, and especially the drawing part, sir. Your lecture was this one very practical, and it will be useful to the our participant. Thank you so much, sir, once again.
Welcome. Welcome.
सस्वत जी.
Yes. Hello, Roman sir.
आपका एक बार वो स्लाइड शेयर करके एक बार देख लो कि whether it's working or not. We will check it.
Yes, sir. Yes, sir. Yes, sir. I shared the screen. Is it visible?
It's loading. Yeah, it's working. It's visible, sir. So we will continue on the topic of post-harvest management and this one, that storage of maize. So our next our next speaker is Mr. Saswat Baria, and he is representing Steamtech Innovation Machinery Private Limited. It's a Gujarat-based company, and Mr. Saswat will be presenting on advanced grain drying and post-harvest machinery, especially of maize. And he has a very extensive experience in scientific grain drying technologies and post-harvest solution. And today he will deliver a lecture on scientific grain drying and post-harvest management. So, Daksab, Mr. Saswat, over to you, and you can interact, and you can interact, and you can this one. Whatever I also request our listener, our participant to ready with some questions also at the end. So over to you, Mr. Saswat.
Yes, thank you, Rohan sir. First of all, thank you IMR for giving me this opportunity, and for giving me and our company Steamtech Innovative Machinery Private Limited. So we are a company based out of Rajkot, Gujarat. And just to give you a brief background, we have been working in the drying space from the past 20 years. And right now we are mainly into agro-commodity dryers and different areas such as incense, then cattle feed, then frames, then papad, and all these sectors. But the topic of discussion for today is the scientific grain drying and post-harvest technologies for maize. And I'll just go with the presentation. Thank you. So we just start with overall some basic introduction. I'll just go through this quickly. So the overall agenda here, we're gathered here to talk about maize, which is catering to all these sectors: ethanol, feed, starch, pharma, bioplastics, sweeteners, dairy, and main considering poultry. So maize is no longer just food; it is an industrial crop. It is a very important aspect of the overall food chain, and we need to do more in preserving what we are actually creating day by day. So this is the Indian maize scenario: the past, present, and future, overall area, production, productivity, and the demand. So the demand, as we all know, is increasing day by day in all these sectors. Currently, the government has also approved the E85 and E100 protocols. So the production of ethanol will increase day by day. So more and more maize will be consumed in this journey also. So why are we after maize across the world? Because it is the main source of protein for livestock, and we're using it extensively for making fuel, and it is also used as to produce ethanol. Sorry, industrial starch that is actually used in all of the major food and beverages and paper, textile, pharmaceuticals applications, and also used in biomaterials and bioproducts. So what opportunity are we talking about here? That, what opportunity do we have here to preserve what we're actually creating? So this is a chart of India, where major states are producing maize. Now, the main challenge here for us right now is invisible. So we actually don't even know, the industry people don't even know, the traders, the stockists, the farmers, they don't, even if they actually know, they are not emphasizing it enough to focus on it and solve the problems. So what is the invisible challenge? The invisible challenge here is this 14 percentage value. So from a long time in this industry, we have been stuck at this number 14 percentage. But what is this 14%? So generally people buy corn, the industrialists buy corn at 14% moisture, but this is actually incorrect, and this should not this should not be happening in future, because 14% corn, yes, it is good for direct use or direct consumption, but it is not good if you want to stock it for more than 2 or 3 months. It needs better aeration practices that are not available right now. So let's just deep dive in briefly into the biology of what this kernel is and how moisture moves around the kernel. So as Pankaj sir just recently mentioned that the kernel is alive. It is actually not a dead thing. So it actually respires even after harvest. So it takes in oxygen, it gives off CO2, and it continuously gives out the moisture. So moisture moves in and out, that affects the quality and weight and storability. So what is moisture? Moisture is basically a friend and enemy. It enables growth and it also enables spoilage if it is more of it when in storage. So what are actually safe moisture levels? Do we even actually know that? In industry, people are actually right now practicing the storage at 14%, 15%, or maybe even 16%. They are buying it and they're just cutting money, some percentage fees from the trader's account, and they're just purchasing it and stocking it. But they don't know what levels should are actually very safe for storage. So let's say 25 to 20% are highly active. The kernel is very active. It is wet, and it actually respires extremely. Then if you go down in 16 to 18% range, it is a caution level that for short term storage for maybe like half day or one day, it is good, but with aerations, with good aeration technologies. Now, if we go even further up to 12 to 13%, it is the most ideal moisture percentage to store the kernel at. And it is very safe because the biological activity is almost halted. And with good aeration technologies, we can achieve the equilibrium. The equilibrium is the moisture will not even go out of the kernel and it will not penetrate the kernel also. So why moisture moves? We actually need to know why moisture moves inside the kernel. So inside the kernel, there at different places the moisture is different. In the center, the moisture at the bottom the moisture is low, and the center the moisture is extremely high. So this is one of the main reasons that why stresses occur inside the kernel, because water causes pressure, that causes stress, and that causes cracks inside the kernel. And these cracks are the main reason the mycotoxins get a chance to enter the kernel from external environment. So as we all know, the respiration never stops. The carbohydrates take in oxygen, give out carbon dioxide, water vapor, and energy, heat inside whatever the storage space that is available. If it is inside a gunny bag, it will give out heat there. If it is inside a silo, it will give out heat there. So that is why we need better aeration technologies for silos, for warehouses, everywhere. So a maize kernel is not just a commodity, it is a living biological system, as we all know. So right now we will focus on the losses. So losses start losses start right after the harvest. So harvest is the beginning of loss. So here we see five stages. So first, it is being harvested. Second, it is being transported. In the third stage, the kernel has to wait for some reason. The truck has to wait outside an industry, outside a processing industry, or outside a grain silo storage. Then fourth, it goes to the storage, and fifth, it is being consumed. But there is loss at each of these stages. In the first, there is high moisture. There can be mechanical damage. There might be field delay. In the second, in transport, there might be condensation in the truck itself. There might be heat built up. There might be vibration damage. In third, then this is the most important one. The corn majority travels in gunny bags or exposed. So it is always uncovered and exposed. Wherever even the traders and stockists are dumping the corn, they are storing it in open, and they are directly then using human labor to transfer it into a pit that will go through a bucket elevator to some silo, or maybe a dryer, or maybe into direct the process. So there we have chances of rain exposure, like sun and UV heat, and moisture fluctuations. If two different batches are also kept side by side, even there the moisture will flow. And in the fourth, there might be fungal growth. If proper aeration techniques are not used, there might be insect infestation and heat and gas accumulation. If the silo is also not built properly, or if the warehouse is not given proper air exits. And fifth, in the industry, uh, after seeing all these losses, we get low quality of product, we get lower yield, like lower starch extractability, and lower value of the final product. Such as in ethanol, let's say if it is ethanol, we get a lower value of DDGS, that comes as a byproduct. So basically, we've identified these seven enemies of maize. First is moisture, then time, then heat, then fungi, insects, poor storage, and logistics. Now, we just go through this, how fungi are developed. Because there are cracks and there are spores on the kernel, then they get a chance to penetrate the outer shell of the kernel, and then they colonize the entire kernel, and that is how they they grow silently. Another main type of mycotoxin is the aflatoxin, the B1 type, that is the most common. And why it is produced? Because it is left out in the field open, maybe during transport, they pick up moisture. In storage, there are poor conditions, or during processing, there are contaminated lots. There are two different kinds of lots that are being used. So even the good grain might get affected because of this. So these are some images of storage rots that might happen due to heating, condensation, mold growth, foul odor, insect infestation, caking, and quality in loss. So basically, these are the invisible losses that we don't actually quantify for. So first is weight, second nutrition, third is starch. There might be starch loss, then there might be quality losses, and finally the monetary loss. So overall, what we're seeing here is that these cost compounds, and they in the end come to the consumer that has to pay more, and that is priceless. So every hour after harvest decides grain quality. Now, why should we dry? Basically to prevent spoilage, to protect quality, and for better margins, better profits, and for safer storage. Now, what is drying? Drying is basically heat plus air plus time. All of these combined in respective proportions, we get drying. Now, what happens actually while drying? There are two aspects. First is heat transfer. Second is mass transfer. People might think that if we just heat up a chamber or a room, it will actually act as a dryer. But in absence of an external fan or an external aeration mechanism, it will not actually dry the kernel. The droplets might even come back, rippling down from the walls back onto the grain. So there are two things. First is heat transfer, where through convection, through conduction, or through radiation, through any kinds of these like principles, the air gets heated and it passes through the kernel surface, and then the moisture comes out from the shell first and then from the inside. So these are two things. First is heat transfer, that the hot air is passing through the kernel, and second is mass transfer, where moisture is actually moving from inside the kernel to the air, and the final exit is the moist air that is coming out of the dryer. Now, this is just a simple explanation of what actually happens stage by stage in drying. The air comes in, then it gets heated up, then moisture is picked up from the kernel. The moist air gets out, you get a dry grain, but it is heated. Heated grain cannot be left, to the silos, cannot be stored. So they need to be cooled down. So this is a chart showing a drying curve, like how grain loses moisture over time actually. So first is the constant phase, where only the superficial moisture is being removed from the surface. This takes time. And after that, the falling rate, where the moisture from inside the kernel gets removed, and we get actual moisture reduction up to, let's say, 12 or 13 or 14%. So this is the equilibrium moisture that I was earlier talking about, the EMC concept. So basically, it is the moisture level at which grain is in balance with the surrounding air. So we can get EMC in a silo very easily, but it is very difficult for to achieve equilibrium in a warehouse or in an open environment. So what is EMC? If air has higher moisture than grain, then grain absorbs the moisture from surroundings. If air has lower moisture than grain, then grain will lose the moisture to the surroundings. So this is equilibrium concept. So drying is not removing water actually, it is preserving value that is created. So basically, coming on to the drying part, this is the evolution of drying. Right now, even 70, 80, 90% of the farmers and majority traders are doing sun drying. We as a company receive a lot of queries from people that how we should dry, and please teach us. So we have our engineers deputed around India. They go from one place to another just to explain this, that the grains in such in such bulk quantities are not meant to be dried on field or under the sun, because there are first thing is they are it will be weather dependent. Let's say if somebody wants to dry 10 tons in a single day, they cannot dry it. But with smart mechanical drying, you can do it. You can also achieve 10 tons per hour. So we are actually catering right now from the capacities ranging 1 ton per hour up to 60 tons per hour for maize and other commodities. Now, what kind of different dryers we have in market? So in market, we usually have three types of mechanical dryers. First is the portable dryer. Second is column type dryer. These both are batch dryers. And third is the continuous type dryer that we are manufacturing in Steam Tech. Now, this is the comparison matrix for all these four concepts. First is sun drying, second is portable dryers, third is column dryers, and fourth is the continuous dryers. Now, the drying methods are different. The energy source in sun drying, it is free solar energy, radiation. In portable and column dryer, you can do it with diesel, pellet, or husk. And in this continuous dryers, you can do it with wood, pellet, diesel, and husk. The weather dependency differs among all, but it will be the best in the continuous dryers because they are in a protected environment. The drying time will also vary. As earlier sir mentioned that it might take, for radiation drying, it might take more than 6, 7, 8 days, up to 8 days. So the drying time is very long in sun drying, then in portable dryers, then in column dryers, and it is the least in the continuous dryers. Main thing here that we need to focus is moisture control. We cannot control moisture if you don't have the surroundings in your hand, in your control. So in sun drying, it will be very poor or inconsistent. In portable dryers, it will be moderate because we'll have an external bucket elevator that will churn the grains. It might also cause cracks in the kernel. Same happens in the column dryers, and it will be the best. The moisture control will be the best in continuous dryers because the kernel has to only pass will only pass the dryer once. So it is a single pass drying system. Last thing that we might focus on is the mobility. So first, sun drying, you have to stay there. It is not portable. Second, portable dryers, it is highly portable. It is good for fields, but considering the Indian landscape, we have a majority of our production during Kharif, and that also happens to be the rainy season. It is not that effective that we have seen. In the column dryer, it is not portable, it is fixed, and the continuous dryers are also fixed, but they are fixed with a reason that they are protected from the external environment. Now, this is a modern drying plant that we actually manufacture. The first is the seed cleaning system. It then goes to the first dryer, then second dryer, and then the third cooling section. So basically, I'll just play a video right now. So we'll just watch one video. So here we actually saw the entire working of a dryer that we actually manufacture, and this is the same plant but just a different model. So second part of the post-harvest management is the silos. So why silos actually matter? In traditional storage, the moisture migrates. There can be, rodent infestation, birds, insects, and there is a lot of manual handling. So this leads to losses. In scientific silos, all of this is controlled. We have controlled aeration mechanisms. We have uniform temperature across the entire silo. We have low losses and better traceability. That is the main of all. So, and everything is automated and you get good quality. So what design philosophy and principles we follow at SteamTech? So we are actually an R&D first company. We do R&D for all of our models. And the video that you just saw, that is also a patented technology from our company. We hold 15 plus patents in different fields. We basically follow convection heat drying principles. We follow that the operation costs should be very low. So we engineer our machines with that respect. So and last is we continuously innovate and we give guaranteed results. Technology should protect grain, not just dry it. Drying actually preserves value for all these industries made for ethanol to get more output from every ton of maize to get better margins. This is the maize value engine. So everything before drying is where the value is actually created on the farm level, where the seeds are being made, where the harvesting is done. And after drying, all these places, the value is preserved. All of this happens only because of drying, efficient drying. So what other countries are doing? So what the world's best grain systems have in common? In USA, there are dryers and silos at farm level. So every farmer has a dryer and a storage facility in his own premises. So they dry immediately after harvest to preserve quality. If they don't have a dryer or a silo, they have an elevator system, co-op system, where they just take their grain and they send it to their silo. In Brazil, they have invested heavily in the post-harvest infrastructure that should be close to production. In India, we have right now the biggest opportunity to build drying capacity before the processing demand outpaces the drying infrastructure. So basically, we come down to India's missing drying infrastructure right now. That we have the current reality is such that we have good production right now. I think, according to the latest news, we did approximately 51 to 52 million metric ton this year. So where we are lacking is storage, the drying infrastructure, and there is sufficient industry demand. So what should we do for the 2047 vision? So we propose the national drying infrastructure, the district model, where dryers and silos are at FPO level. Every FPO should have a dryer and silo, and this has to be a multi-commodity dryer. So it is not only for maize, but it also for soybean, groundnut, pulses, let's say all kinds of dal. So everything can be dried from a single dryer. That is our proposition. So a typical drying capacity may range from also 1 ton per hour up to 5 tons per hour, and it may be 10 tons per hour, depending on their local capacity and requirements. The silo capacity may be 3,000 metric tons, and serving area may be 5,000 acres. Farmers approximately maybe 100, 200, 500 farmers can benefit from that single FPO. So what we actually propose is drying as a service, where FPOs or any entrepreneur or any public-private partnerships can install these dryers, and they offer the drying service for a fee. So this is the most simplest and easily scalable kinds of model. that we can actually implement. The final thing, I'll just end here. Every kernel has already been paid for. So every maize kernel that we are producing has, been given fertilizer, water. We have invested in labor, diesel, time, sunlight, land, seed, everything. Drying protects every investment that is already made. So we are protecting what the value is, what the value actually is. And final message, drying does not create value. It protects every value nature has already created. Okay, thank you. If anyone has any questions, I'm happy to answer them. Virendra sir, actually, the cost depends on the capacity that we are going for. And tentatively, what we say the budgetary price for 1 ton per hour dryer, it may range from 15 lakhs up to 25 lakhs. But all of this is very tentative, and it depends on what kind of input moistures that you have, what kind of output moisture that you require for your drying needs. So it depends on all of these processes. Yes, Roman sir.
Hello, if anyone has question, please ask. Shashwat ji.
Yes, sir. Yes, Manish sir.
Okay, thank you so much, Shashwat ji.
Yes, thank you.
I
Thank you
think
once again,
some
sir. For
question
inviting us.
words in the chat box. There is some questions. What is the ideal harvest moisture for selling corn?
We actually get requirements for grain drying from 22% to 14%. So ideally, what we assume that the corn might be shelling at 22 to 25%. That is what we assume.
Okay, Saswati, thank you.
Thank you.
Close the today's sessions. Thank you all.
Thank you, Saraswat ji. Thank you very much.
Yes, thank you. Thank you, Roman sir.
Okay.